In this video we're going to look at shallow foundations. You'll recall from the previous video that there's shallow foundations and deep foundations. Um, Shallow foundations are generally less expensive because you're working close to the ground, close to the ground surface. You're using less sophisticated equipment, normally it's manual labour. You are also using less expensive equipment as well. Deep foundations require specialist, very expensive equipment, and shallow foundations generally take less time. So you'd use them when the soil is able to support the load. So for a medium-sized structure such as a house, a shallow foundation is normally enough if you've got a reasonably competent soil. However, if you have a rubbish soil, then maybe a house needs to have a deep foundation. Likewise, if you have a high load, like say a bridge or a high-rise building, then even if you have a competent layer of soil on the surface, it's possibly not going to be enough for the load, and so you'd need to go into a deep foundation. So where you can, you'd use shallow foundations. There are generally three different types: strip, pad and raft. There are variations on these themes and there are more specialized ones as well, but these are the ones that are commonly used. So we'll look at each one of those in isolation. So a strip foundation spreads the load from the structure along a strip, basically. And this is really good when you've got, say, a house or something like that, where the loads are distributed along a wall, for example. So for example, here's a load-bearing wall going to be going on top of this, and you've got the strip foundation along there. You can see that it's basically a concrete laying operation, so there's reinforcing there as well. You can see that the guys have put formwork in, so they've dug in a trench. Normally strip foundations maybe go down, I think the standard is 600 mils below the ground level, so that's 600 deep there. So you dig a trench, you'd put the formwork in, you put the reinforcing steel in, making sure that you've got adequate cover and spacing of the steel. You'd have the rebar for the wall foundation, in this case it's going to be brick, sort of cast into the strip foundation so the wall and the strip are tied in together, and then you'd cast the concrete, normally just using normal concrete pouring techniques, either from wheelbarrows or from a concrete pump. And the concrete doesn't actually have to be too strong. It's not really acting in tension, it's just acting there as a compression element, unlike a beam which has to be able to cope with significant tension and significant compression. In this case here, a strip foundation is supported all the way along its length by the soil underneath. The next foundation is a pad foundation. This is where you have a structure with columns bringing the loads down. So instead of having the loads brought down along the length of a wall, you have columns maybe at 5 to 10 meters. So it's not really worth putting concrete in between the columns, because if you put concrete there, it wouldn't actually be doing anything. Once again, you're digging down maybe 600 mils, putting in reinforcing, putting in the rebar for the column, and then you'd put formwork around it, and then you'd cast it all with concrete. You can also use the pad foundations for steel or timber columns, in which case you would have a bracket there which the column can be bolted onto. So steel or timber works with pad foundations as well. And you can see there's different variations on the pad foundation. Building 183 the extension is on pad foundations. The reason why they could do that with a 3-story high building was because underneath that building is a layer of basalt. So they had a very, very strong layer close to the surface, so it was worthwhile putting in pad foundations. On lesser soils, you may well have done a deep foundation for a 3-story, 5-story high building. But at Unitech we have a layer of basalt underneath. So most of our foundations are pad foundations or shallow foundations. A raft foundation spreads the load over the whole area. So that's where you've got quite a high load, or you've got a marginal soil. So you want to utilize the whole area of the foundation to spread the loads out. You can see that it's not just one straight slab. There are foundation beams cast into it deep areas if you like, which provide stability, rigidity to the raft. The raft has to act as one structure. If you just had a flat slab, then there are going to be points of weakness, and you can see that they've put the foundation beams underneath any load-bearing walls or anything like that, but it's still all tied together with these slabs here. The whole raft will act as one structure. It's basically taking all the loads from the building and distributing it into one element, and that reduces the chances of differential settlement, and it also means that there's a much larger area acting to support the building and reduces the amount of settlement as well. So here's a picture of a raft foundation ready for a pour. So you can see that they've trenched in the foundation beams. They've got reinforcing steel in those, so they are like a strip foundation if you like, and then they are tied into the slab on top of it. There's waterproofing there to stop water from migrating up into the building. You can see also that they've got penetrations there for the services as well. So if you've got toilets there, for example, you'd actually have to be putting the pipes through it before you cast the slab rather than try to drill it through when you've got it. So you'd be putting the pipes and underground services in and bringing them into the building as part of this as well. And that's the same with the other ones, other structures as well. Once again, it is all it's just a concrete pouring job, reinforcing steel all tied together, formwork around the sides, the top of the formwork being the top of the slab, so you need to make sure that you've got that level quite correct, because the people, when they lay it, they'll be screeding off the top of that formwork to get the right levels. So you need to make sure that the top of the formwork is actually at the correct level.